What is going on, guys? Welcome back to another Universe Sandbox Squared video. Today we're going to be checking out what would happen if we made all our planets from Mercury right out to Pluto strike the Sun. Now this is not going to happen at once. Of course, it will take time for every planet to reach the Sun. We are not going to launch them from a particular distance. We're basically going to zero the velocity of their orbits, which makes them head towards the Sun. So let's start with Mercury by going into actions. Our simulation is paused, so it all happens at once. Zero velocity. Now Venus, zero velocity. Earth, zero velocity. I just pressed add moons to a planet, that's fine. Zero velocity. Zero velocity for Mars. That's technically not a planet, so we'll skip that one. Vesta, that's more of a moon or asteroid. Jupiter, zero velocity. Saturn, zero velocity. Uranus, zero velocity. Neptune, zero velocity. Pluto, zero velocity. So that's all of our planets at a zero velocity stage, and now we should see that all the planets should head towards the Sun, of course starting with Mercury hitting the Sun first, just logically because it's the closest to the Sun. So Mercury is fast approaching. Oh, I don't want to miss it. We missed the Mercury. That's fine. It wouldn't have been big enough to see much of, but we will be sure not to miss Venus's collision. I was hoping to catch that collision, so I might as well track Venus just in case and slow it down, see if there's been any effects. Of course, the heat is increasing at a temperature of 770 degrees. How's other planets doing at this moment? How's Earth, for example? We seem to be fine. Our temperature has not increased very much, but that will change. And Venus is still increasing quite rapidly. The Earth is starting to pick up speed, 18.3, slowly increasing. It seems like Venus seems to be increasing very quickly because it's getting closer and closer to the Sun, more gravitational pull. And the temperature is nearly up to 800 degrees, and that's happened within a few days, getting quite close towards the Sun. Atmosphere would have been burnt off by now. And Earth increased by 0.1 so far, so not much. So over time, the increase in temperature gets right up to, I'd suspect, nearly into the 1,000 as it approaches closer, if not more. By looks of where we're going, it's going to be a bit more than 1,000 degrees that Venus will get up to. So it's just surpassed 1,000 degrees. Earth at this moment, 16.5. So we are getting a noticeable increase in temperature, not into the hundreds just yet, or the boiling point of water. Venus up to 1,200 and still increasing. Now I want to slow it down for the actual collision, and I'll see the temperature as well. So the temperature, by the time we get so close to the Sun, is increasing that much. It nearly increases to 3,000 degrees in under an hour. And of course we want to slow down for the actual collision. So we'll zoom into here. We'll slow it right down. Believe it or not, this is only seconds per second. So still quite a fast simulation compared to real life. And definitely atmosphere burnt off. We're nearly up to 5,000 degrees. That's a big increase in a few hours time. So we are slowing it down. Slow it down now. And we want to see the initial collision as slow as we can get it. Don't want my computer to crash though. Get rid of our stats. Basically a ball of mantle, magma, and it's about to collide with the Sun. At this point, how's the Earth doing? Earth is 17.1 degrees, so not so hot. At this point, 8,000 degrees for Venus. So very, very hot. and higher levels of radiation, of course. And a velocity of 585 kilometers a second. And at collision, of course, there'll be a shock wave that will append off the sun's surface. And we have got collision. And as we can see, the sun's actually changed temperature to a blue color. I think I said temperature has changed color from orange to a bluer color. That's just due to the amount of energy being inputted into the sun. Mercury had a collision, now Venus. What's going to happen once we get to the sun? Now, to speed it up, we will increase our simulation speed just so we can see what would happen to the Earth over a high amount of time. Now, this would take a few days, weeks for us to reach the sun. And pause it here. What's our stats? I think because we're going so quick, it's not keeping up with the temperature. For whatever reason, it seems like Earth has a much more blue filter compared to of that Venus had. That's just due... Nope, my bad. I just remembered that this Earth is now reflecting blue light instead of yellow light. That's why it looks a bit more blue compared to orange, like we usually see. So, as we get towards the sun, of course things will increase. We can actually see the shock waves still from the Venus collision. We are 102, most likely more at this point. Way more. I think it's just because we've got the simulation going so quickly that it's bugged out the stats, but our main thing we want to look at is the collision. Again, I would imagine that water would be all gone, temperature probably in around like Venus had, and our atmosphere would be completely burned off. So there would be no chance of survival from this, even if we could divert off the collision course. So, of course, we can see some swirls of energy on the sun, and this should be a larger impact compared to that we had of Venus. Of course, we're up to 3,000 degrees now, so a very high increase as we approach the sun. And we've got some atoms and some matter coming off the planet as well from the huge gravitational pull of the sun and repelling of the sun. And we should see collision in any moment. Again, water and the mantle would probably be very exposed, and probably some mass would be lost. So this is kind of an inaccurate testing that we're seeing right now. Color change in the sun? None, by the looks of it. That could change as the collision goes on. Definitely can hear the sound though. And Earth is engulfed into the radiation of the sun. Now, over time, we have a good expansion. The sun is actually increased to 73,132 degrees Celsius. And our mass of the sun, still the same. How about a radius? A radius has increased. That was expected. That has increased by 1% by those stats. So our next collision, I believe, is Mars. Now Mars will take a long time to get there, so this is another simulation that we just basically want to get out of the way. It's more Jupiter that we want to look at. We have looked at Jupiter already, but I want to see the key. Damn, I missed it again. That's all good, but we can still see that a shock wave would occur. This is probably something on a larger level that I'd expect for the Earth to have. Now, believe it or not, the temperature, no, that's the radius. The temperature around the same, as in for the radius, still the same, 1%. Larger than what it used to be, and we've got that shockwave going around the entire sun. This would send off solar flares and radiation in space, and we've actually got a rotation on the sun now. Now our next planet, I believe, is Jupiter. Now This is just my thoughts. Could be wrong, could be right. By the looks of it, we are right. It will be Jupiter. And this is our largest impact that we'll have on the sun, basically. And, I nearly missed it completely. I just sped it up by a few months just so we can get the best look possible, and speed it up because we don't want to be here forever. Again, the new blue lighting from the sun reflecting off Jupiter. I'm guessing this would either enhance the color a bit more, this collision, because in the last video we did with Jupiter hitting the sun, it turned blue. So it could turn a darker blue or even to a green. But I suspect it would stay the same and the mass and the radius would increase. Now as we get there, temperature very high, thick atmosphere equals higher temperature. Looks like it's moving faster, it's just because the size of the object. It's mind over matter. Although the velocity is in around the same at each impact. Now, before this collision, I want to see where where Saturn is. So Saturn's still quite off, guys. Because it's further out, it's got more velocity to pick up. And less gravitational force, basically. So it will take longer, meaning we'll have to speed it up a bit longer. And we'll just slow it down. Oh, wait, what? I think I lost it. Okay, I paused it in time. I have no idea what happened there. I just wanted to check the stats before we go and take a look at the impact. The sun is, of course, 1.01, still the same. So let's take a look at this impact. Speed it up a bit. We want to go into the seconds. And we have impact. Now look at that. You can hear that roar coming from the sun. That's a very large roar. Whoa, that's some explosive force, guys. Wow. This I saw in the last video, but this seems like it's a lot more force. Even my graphics card cannot keep up with it to a very zoomed in status. It's just lagging too much. So we have to view it from this direction, and it's barely at 30 frames per second. Wow. That is a lot of energy coming off the sun. Dare I say, that could implode the sun completely. Look at it. Wow. That is a lot of radiation coming off the sun. Whoa. What the heck happened? Whoa. Whoa, okay. Okay. Increased temperature. I think that's because we've increased the different types of gases, which changed it to a huge gas giant, practically. And I'd expect that the temperature would, if this holds, would actually drop. My god, guys, we've destroyed the sun completely. Wow. So all that energy coming off is actually our heat potential. Wow. Look at it. It's only 5% of what the sun was now. Oh god. Look at all the solar radiation, guys. Some parts being as large as the Earth. 3 times as large. 4 times as large. Practically, there'd be very much more of those as well. Wow. That is huge. Very huge impact. All that coming off is solar radiation going out towards all the other planets. And we've still got more collisions to go, guys. Now I'm interested to see what happens with Saturn. What's Saturn going to do? Have we lost the rest of our potential? It looks like we have. It looks like we are not going to have any more collisions. What is that blue line? Okay. So interestingly enough, we are most likely not going to have any more collisions. That was amazing. Everything is lost. Gravity. Everything. lost from Jupiter's impact. Wow. So that would be what would happen if every planet up to Jupiter struck the sun. And it looks amazing. It's going like in a three-dimensional globe shape. Look at it. That is beautiful. Saturn going one way, Neptune going the other. Any planets going to stay together? Maybe. But guys, that is what would happen if we made every planet up to Jupiter strike the sun. Now let's take a look at one last time at what we created finally. What did we create? We created a brand new gas giant from one sun. From one sun, guys. Only one sun did this. And it seems like it's going to be at a very high temperature for like forever. And where's everything else at this time after thousands of years? Basic physics, it goes off in a straight line. So guys, that's it for this video. Remember to subscribe for more content. Twitter and Instagram links are in the description. Please leave a like on this video if you enjoyed it. And I'll see you guys in the next video.